Hello friends, and today let's do a session on mixtures and alligations. According to me, this is not a new topic, right? This is just the amalgamation of averages, ratios and proportions and percentages maybe. But this is not a new topic. So even if you skip this topic, right, you would be able to solve the questions, right? But having said that, I am not suggesting you to skip this topic, but to just see how do we solve the examples with a mental logic, so that our calculations become very easy. So without wasting any more time, let's go to the agenda for today. So agenda for today is again very simple. We'll do the basic concepts and then the applications. But before doing it, let's do a 1 minute silent meditation so that we can concentrate on this video more. Just open the clock on your desktops and just watch the second hand for around 1 minute. Just keep your concentrations on this second hand. So we can now start. So let's go to the basic concepts. So, we did this meditation because I feel that this meditation helps in creating the right kind of environment in learning, right? You may skip this if you don't like it, right? But I suggest that you do it in your daily studies as well, because it would help you increase your concentration to many folds. Just try this for around 21 to 40 days and you would see a great improvement in your concentration and you would be able to grasp more, right? So let's go to the basic concepts. The first concept, there is just one concept, right? So we are dealing with mixtures. Mixtures are what? Mixtures are two or different varieties mixed together, right? So there are two or more varieties which are mixed together, right, to form a particular mixture. These varieties might be priced at different prices, right? So for example, if we mix two varieties of tea, one at let's say a cost of 58, another at a cost of 62, the resultant cost would be somewhere between 58 and 62, right? It is somewhere between these two, and it would depend on what is the ratio of variety A to the ratio of variety B. So main motive of mixtures and alligation is to find this ratio, right? So we'll take one example and then we'll see what is the concept of alligations. So question says a man mixes two varieties of rice at rupees 16 per kg and 20 per kg. In what proportion should they be mixed so that resultant mixture is sold at 18 per kg, right? So now he mixes two varieties at 16 per kg and 18 per kg. The question says he has to mix such that he gets the resultant at 18 per kg, which means let's do it with a conventional method. So let's say he mixes x kgs of first variety and y kgs of second variety in the mixture, right? Which means he spent 16x for first variety and 20y for second variety. Now what is the total he has? He has x plus y, and at what price he is selling it? At 18. Now we are told that there is no profit. No, we are told that there is no profits as such, right? There is no mention of profit, so we can assume that he is selling it at the 18 rupees, which is equal to the cost price, which means 16x plus 20y is equal to 18x plus 18y, right? and if we reduce it, it becomes x is equal to y, which means he is mixing them in 1:1 proportion, 1:1, right? So he is taking equal amounts of variety A and equal amounts of variety B. Now let's go to the second part, which says he wants the resultant to be at 17 rupees. So using this logic, it becomes similar, which is 16x plus 20y is equal to 17x plus 17y, which means x ratio y is 3:1. So if he mixes 3 kgs of x, he has to take just 1 kg of y, so that the resultant becomes at rupees 17 per kg. So this is the basic method of mixtures, right? This is the basic solutions of alligations. Now if you just see what we are doing here, we are subtracting 17x from 16x, right, and 20y from 17y, right, 17y from 20y to get this ratio. Can we make it in a easy concept as well, so that we don't have to write all these equations? Yes, we can. So that is the basic method of alligation. So you just write 16, 20, right, which are the required quantities, which are the given quantities which are mixed. What we require is 17, so 17 is the average, right? And now you just subtract this 20 from this 17 from this 20, and you would get a 3, right? So you write 3 here, you just subtract 16 from this 17, you would get 1 here. So the ratio would be 3:1. So variety of 16 per kg should be 3 times the one which is 20 per kg. So that's the simple way of calculating it. So even we can solve it without writing these equations and using this diagram generally, right? And hence we would get the answer. Or we can even write the formula. So x ratio x by y would become mean price minus absolute of, right, price of y. We have to take absolute of it even if it is negative, divided by mean price minus price of x, right? So mean price is 17 minus price of y, which is 20, so absolute value is is 3, it would become 3. And in second case, mean price 17, price of x 16, so it would become 1, right? So 3:1. So this is a simple and easy formula to commit, right? I don't generally recommend formulas, but in this case the formula is pretty straightforward and easy. And now that we know the basic logic behind formulas, we can anyways do these questions without formulas, right? So let's now go to few questions. I'll give you 2 minutes for each of them, and let's try and solve this. So first question says, in what proportion must a 25% alcohol be mixed with 50% to get 40% strength? So just 2 minutes for you, try and solve it. So I think you must have solved it. So in what proportion 25% is mixed with 50% to get 40%? So mean is 40%. So amount of 25% divided by amount of 50% would be mean minus amount of 50%. So amount of 50%, mean minus 50%, right? So mean is 40. 40 minus 50 is 10 divided by mean minus 25%, which gives you 25. 40 minus 25, which gives you 15, right? So this becomes 2:3, right? So what we have done is, if we take this thing here, it is 25, here it is 50, right? And here it is 40. What we require is a 40% solution, right? We are given 25% solution, we are given a 50% solution, but we are required a 40%. So this would become 10 and this would become 15. So the ratio is 10:15, or if we simplify it, it would become 2:3. So as simple as that, right? Now let's go to next question, which says a 70-liter mixture of milk and water contains 10% water. How much more water should be added so that the resultant mixture become 25%? Again, you have 2 minutes or less than 2 minutes for it. Just try and solve it. So let's do it. We are given a 70 ml 10% water mixture, right? So in this the water percentage is 10. Now in this we have to add 100% water, right? Pure water means 100% water, and the resultant should be 25%. So what we have got is the resultant, on one side it's 10%, on another side it's 100%. Here the resultant has to be 25, right? So this means it comes as 75, right? Here it comes as 15, which means it is 5:1, right? So the proportion of the mixture and the original water is 5:1, right? So 5:1 is what we got. Now which we have 70 liters of mixture, which means if it is 5x, then x would be 70, x would be this, which is what? Which is 14, right? And for every 5x liters of solution, we have x liters of water, so x should be 14. So we require 14 liters of water to be added to 70 liters of mixture, so that we get a 25% water mixture, right? So as simple as that. So even if it's percentages, right, we have to just see that we are adding certain percentage here to get certain percentage, right? Now if we are adding water, it has to be 100%. For example, if the question says a 70 liter of milk and water contains, let's say, 90% milk, right? How much water should be added so that we get 75% milk, right? Now what we would have done is, because we are adding 100% water, we should have calculated here what is the percentage of water. So we would have subtracted 90 from 100 to get 10% water, and the resultant water content should be, so this is milk, the resultant water content should again be 25%, right? So the question reduces to the earlier problem only, right? Just see that how to reduce the problem to the simple one. Next question says, an alcohol mixture having ratio of alcohol as 1:5 is mixed with another having this ratio as 1:3. The resultant is 1:4. Resultant ratio of alcohol and water is 1:4. So in what proportions these two are mixed? So even if it is proportion, right? So 1:5 means that amount of alcohol in first solution is 1/6, amount of alcohol in second solution is 1/4, right? And amount of solution in resultant is 1/5, right? So now just substitute these values in our matrix, the alligation matrix, right? Here it would become 1/6, here it would come 1/4, here it would come 1/5. Just subtract them and find the ratios, right? Let's do it. So here it is 1/6, here it is 1/4, here it is 1/5. Now when we subtract 1/4 from 1/5, we would get 1/20, right? And here we would get 1/30. So the ratios would be 1/20 ratio 1/30, right? And it would be reduced to 30:20, right? If you reduce it, it would become 30:20, which further can be reduced as 3:2. So this would be our resultant. So these are simple questions. They are very much likely in our CSAT exam. Next question is almost a similar one. We have just added a component of profit here, profit and loss here. So just try and do it. You have 2 minutes to do this question. Let's do it. He says that a grocer sells a mixture of tea at 20% profit. If he mixes two varieties of tea, 65 per kg and 82 per kg, what should be the ratio of these varieties so that he earns 15 per kg? So his profit is 20%, which he again says is equal to rupees 15. So 20% profit means it is if CP is CP, the profit is 20% of CP, right? So it's CP by 5. We can write 20% as 1 by 5, right? We should now on just try to reduce as much writing as we can. So we should remember that 20% is equal to 1 by 5, right? So this is equal to 15, which means our CP is equal to 75. So by mixing 65 and 82, we should get 75. How do we do it? Simple, we will use that matrix, or we can directly write. So if this is variety X is equal to 65, just do it in question itself, right? And this is Y is equal to 82. So X ratio Y we have to find. X by Y would be the difference of 82 minus 75, which is 7, divided by the difference of 75 minus 65, which is 10. So 7:10. As simple as that. We don't even have to write things, right? Just try to reduce as much writing as possible. By the end of this course, you should be able to do around 30 to 40% questions orally. Now let's go to next question, which says a grocer sells a mixture of tea at 20% profit. If he mixes two varieties of same in 2:3, what is the profit earned? So this is another concept. This is not allegations per se, but yes, this can be nevertheless a question in a CSAT. So this is basic question of ratios and proportions. Just try to do it. Another 1 minute for this. So let's do it. It's very simple. So just leave this statement first, right? We have to firstly find the cost price, right? What would be the cost price? He is mixing 65 per kg and 82 per kg in 2:3, which means if he takes 2 kgs of 65, he would spend 65 into 2. He has to mix 3 kgs of 82, right? So this would come out to be 373. If you calculate it, it would come out to be, I think, 373. Now total tea he has is 5 kgs. So what would be the cost of per kg? It would be this, right? Which would become 74.6. Now this is the cost price. He is earning 20% profit over the cost price. So profit would be 74.6 divided by 5. Whatever is the answer would be your answer. I think it was 14.92. Just calculate it for yourself and see, you get the right answer. So this is very easy. This question is also similar to the one. Here we are mixing 3 varieties of teas, right? So 65, 75 and 82 in ratios 2:3, 4 to earn 20% profit. So similarly, in the similar way as we did last question, we would do this. So we take 2 kgs of 65, 3 kgs of 75 and 4 kgs of 82. We'll find the total cost divided by the weight which we got, which is 2 plus 3 plus 4, 9 kgs. We'll get cost per kg and we'll then calculate 20% profit. So this is very similar to the one. So even if there are 3, 4, 5, 6 varieties, you use this logic to calculate the cost price, right? So that's how we do it. Now the last concept in this is mixtures and replacements, right? So here we'll do a question, right? This seems to be a tough question. Usually this is asked in CAT. I have not seen a question of this much difficulty in CSAT, and I don't think that there would be question of this much difficulty in CSAT, but nevertheless we'll do the concept and see how do we do it. So it says a 7-liter vessel contains a mixture of milk and water, milk being 49% of total volume. A few liters of water is removed and replaced by same volume of water. This is done twice and the final mixture thus received contains 9% milk. How much volume of mixture was removed? So when you remove something, right? So for example, what do we mean by 49% of the total volume? Right, this means if we have 7 liters, right, the amount of milk is 7 into 0.49. This is the amount of milk. Now if we remove 1 liter out of it, if we take 1 liter milk, 1 liter solution, how much milk would be there? It would again be 49%, right? It would again be 0.49, right? So this is again 0.49 even in 1, right? Now if we remove x liters, right, or if we let's say remove a liters, then how much milk would be removed? It would be a into 0.49, right, which means 0.49 times a milk is removed. So what is the remaining milk in the mixture? It would be 7 into 0.49 minus 0.49a, right? After the first removal, this would be the amount of milk, right? Now out of this we again remove a liters, right? We again removed a liters. Now if you see, the percentage of milk is not 49%, it has reduced from 49%. What is the percentage of milk now? It would be this quantity, let's say it's Q, right? Let's call this quantity as Q. So we'll call this as Q, right? So this is the milk, this is the amount of milk, and or let's say let's find the percentage of milk, right? So this divided by 7 multiplied by 100, let's call this the new percentage, so it would be Q percent. Now out of now the milk is replaced with water, right? So the volume of milk remains the same. Now we have again 7Q, right, by 100, or let's not multiply it by 100 here and call it Q, right? So now we have 7Q, which is milk. Now out of this AQ has been removed, right? So this is what we have left with. Now this divided by 7 is given out to be 0. So it's 9%, so we can write it as 0.09, right? If we simplify it further, what would we get? We would get Q multiplied by 7 minus A divided by 7, right? Now just substitute Q here and it is equal to 0.09, and if we substitute Q here, we can simplify Q as well. We can take 0.49 common, so Q would become 0.49, let's take it common, multiplied by 7 minus A, right, divided by 7, right? This whole thing is multiplied by 7 minus A divided by 7, right? And this is equal to 0.09, right? Let's transfer this 0.49 down here. What we would get is 7 minus A whole square divided by 7 whole square, right? And this would become equal to 0.09 divided by 0.49, right? Again simplifying it further, let's write it, let's copy it. This would become 9 by 49, right? We'll take a square root of this. What we would get is 7 minus a this whole divided by 7 is equal to 3 by 7, right? It is 3 by 7, so a becomes 4 liters. If you calculate it, a is equal to 4. So calculations are pretty lengthy, right? But I think you got the gist of it, right? So the main crux is when we remove the mixture first time, the percentage of milk changed. It was not now 49%, it became something like a Q%, right? Now if we do 3 iterations as well, right? So we would write it as, let's say, R%, right? But the amount of final milk would be final solution would be 7 only, because we are replacing it with water, right? So for the next step we would have taken the same thing, right, this, and we would have replaced Q by R, and so on and so forth. We would keep on going, right? So if you see, the general formula becomes very easy. It becomes amount of final divided by amount of original, right, is equal to 1 minus, we have said that a is removed, right, and we have said that total volume was, let's say, V, right, this raised to power n, where n are the number of iterations. So in this formula, amount of final was 9% of V, right? So our final amount was 9% of V. Just let's see whether this formula works. So 9% of V, and initial was 49% of V. V and percentage would get cancelled, right? So we would be left with 9 by 49 as we saw in the above calculations, which is equal to 1. So if we take this 7, if we take the 7 inside right here, we would get 1 minus a by, which is a is the volume removed, 7 is the original volume, this square, right? So this is what we wrote above as well. So from this formula it would be very easy to get the answer. So I would again suggest to learn this formula as well, or if you just forgot this formula in the final exam, just try to solve it as we did it above. The only point you have to keep in mind is each time we replace the original mixture with some pure substance, the ratio changes, right? The percentages or the ratios changes, so you have to keep that thing in mind. So this is all about ratios, so this is all about mixtures and alligations. I hope that you got the concept right? It's not a very tough concept. I think there is a lot of hoopla in aspirants that mixtures and alligations is very important topic, and there is a lot of tough concepts which we have to learn. There's nothing like that. They are simple arithmetic, they are simple problems of percentages, averages and all that stuff, right? So keep them simple, try solve as many problems as possible. So that's it for today. So we'll wrap up this session. Thanks for watching this video and all the best.